In the last video, we talked about entity fixed effect. Now we're talking about time fixed effect. These are effects which are common for all the entities, but differ across time. So they are evolving across time equally across the entities. One such example might be from our example of traffic safety, that safety standards might change over time, but they are equal across the whole country, like a national standard. So, to revert to our example, we can just cut the effect of culture on traffic deaths in our model and add some time fixed effect instead. So, what we have is the fatality rate. This is our y. We have the beer tax. This is our x. We have the slope, the effect of a change in beer tax on fatality rate. This is what we are looking for in our model. We are looking for determining the causal effect of a change in beer tax on the fatality rate. But what if there are some omitted variables which are common to all the entities? It's common to all the states, but it might differ across the years. Okay. So then we have this time fixed effects regression model, and remember that we do not have a alpha, the entity, the change in entity slope, or the entity slope. We have a slope which is specific to each time period. So we have intercept for each time period. Okay, so what would this look like? This would look like such that we have the beer tax, and we would have the fatality rate, and we would have this linear equation, and this would be the fitted fatality rate, right? And each year would have its own intercept. So this would be t equals 1, this would be t equals 2, and then we would have this would be lambda 1, and this would be lambda 2. No, 2 and 1. Okay, I can do that better. This would be lambda 1, and this would be lambda 2. So you would have, in our example, we have 7 different years. You would have 7 different equations, each with its own slope. So this slope would vary across time. No, this intercept would vary across time, but not over entities. So, what is the lambda? Well, they can actually be thought of as the effect of year t on the fatality rates. So, and you can think of the intercept as the value of y when x equals 0. So this would be the fatality rate prevalent in that year given no beer tax. And these effects might be national variables, like the gross domestic product, or U.S. wide economic trends. And the two ways to estimate this model is just as as we saw in the last video. We can use the least squares dummy variable method or the within transformation. And if we do the least squares dummy variable method, then we just make we have the y variable, we have the x variable, and we have the time variable, and we have the entity variable. And what we do is just to make a dummy for 1982, and then we make a dummy for 1983, and so on. And these are equal to 1 if the year fits, and 0 otherwise. Okay, so then we can just use this data to estimate the regression model by OLS. And then we would have the fatality rate, and we would have a common intercept, and we would have the effect, the slope, the effect of 1 unit change in beer tax on the fatality rate, plus the coefficients on the dummy variables. And these coefficients would then be the change in intercept from the base case. Remember, if you have if you have dummy variables, then you have one less, or you include one less dummy variable in your regression, then you have instances. So for instance, we have 7 years of data, so we only use 6 dummy variables for the time period, and the 7th case is when all these 6 dummy variables are equal to 0, then we are left with the base case intercept. Okay? So these deltas, delta 2, delta 3, and so on, up until delta 7, they are just the change in intercept from the base case to this year 2, year 3, and up to year 7. And remember that you can leave out any of these 7 dummy variables, and the dummy variable that you leave out, that would be the base case. So, and we have this common intercept in our regression, so we do not include all 7 year dummies. That would actually create a perfectly multicollinear situation, and we could not estimate our model. And the main takeaway is that the time fixed effects regression model allows us to remove any bias, omitted variable bias, from variables which are equal across entities but change with time.